Math 1314, Tyler Junior College, Section 2.8, Distance, Midpoint, and Circles. In this last video in the series for Chapter 2, we're going to discuss three, I don't want to say unrelated or miscellaneous topics, but they just didn't fit nicely elsewhere, so we're going to talk about them now. The first thing we're going to talk about is the distance formula. The distance formula is a formula, well, its name says it, it's a formula that calculates distance. More specifically, the distance between 2 points on a coordinate plane, assuming that you know the point's coordinates. You'll notice that I have a generic picture drawn of 2 points labeled x1, y1, and x2, y2. And the question is, what is the distance in between them? Of course, D is a good letter to use for distance, so we'll go with that. So how can we even begin to approach this? Some people might think just get out a ruler and mark it and measure it. And I guess you could do that, but that's assuming that you have a picture to measure. Plus, these points might be so far away that it would be difficult to use a measuring device to measure the distance between them. And you need to know what scale to use. I don't even have this marked up on the X or Y axis, so I don't know if one would go here representing 1 inch, or if one would go over here representing ½ a foot. So measuring is kind of not what we're looking for. We're looking for something a little more theoretical, something that depends only on the ordered pairs that define the endpoints of this line segment, whose distance we're trying to find from the beginning to the end. So how can we find this? Well, one trick to a lot of geometry problems, and this really pays dividends for those of you going into calculus, is to draw some extra parts to the picture. Maybe some extra line segments, look for extra angles, maybe draw some shapes or something. But in this case, we've seen a situation like this before. When we were discussing slope, we were talking about the slope of a line, and the line was defined by 2 given points. And do you remember the picture we had for slope? Slope was defined as rise over run, where run is the distance that you go horizontally in traveling from one point to the next, and the rise is the distance that you travel vertically. Can we take advantage of this? We can, because the run and the rise are perpendicular. The run, the rise, and the distance we're looking for together make a right triangle. Now, why is that advantageous? Because there's a theorem that relates the lengths of the 3 sides of any right triangle. You probably know it as the Pythagorean Theorem. There are other names for it, such as the Gogou Theorem, which is based on Chinese mathematical history, but I invite you to research that on your own. I shall continue to call it the Pythagorean Theorem, or as some people call it, the Theorem of Pythagoras. Most people think they know what it is. If I ask people what's the Pythagorean Theorem, they usually say, a squared plus b squared equals c squared. But if I ask them what does it mean, they're like, I don't know. The Pythagorean Theorem, the Theorem of Pythagoras, Gogou Theorem, whatever you want to call it, is a statement about the 3 sides of a right triangle. If they're labeled like this. I don't like this picture. I don't like that labeling. And the reason I don't like it is pretty simple. The choice of A, B, and C is completely arbitrary and completely meaningless. There's a picture I prefer. There's a version of the Pythagorean Theorem I prefer. Not by labeling the sides A, B, and C, that is so generic, but by calling them by their proper names. Most people remember that the longest side of a right triangle is called the hypotenuse. I don't know why they remember that. You never use that word except here. The other 2 sides are called legs, so we'll just say leg and leg. My version, or the version of the Pythagorean Theorem that I prefer, makes no mention of A, B, or C, but rather leg, leg, and hypotenuse. The square of one leg plus the square of another leg is equal to the square of the hypotenuse, which I'll abbreviate HYP. So however you do the Pythagorean Theorem, We're going to do it on this picture. So if we did the Pythagorean Theorem on this picture, the hypotenuse is d, so we could say d squared equals, the legs are currently represented by run and rise. So we'll say run squared plus rise squared. Now, we know how to calculate run and rise if we know the coordinates. So we can calculate the right side, and therefore we can calculate the distance. Do you remember how you calculate the run? The run is the difference in the x's, second x minus the first x. And the rise is the difference in the y's, y2 minus y1. At this point, we almost have our formula. But I want a formula that says d equals, not d squared equals. We've been down this path before. What can I do to both sides to get the d by itself, to get rid of the square on it? Answer, square root both sides. If we square root the left side, we get just d. But if we square root the right side, we can't cancel the squares. We cannot cancel the squares. Do you remember why? Because if you're going to try to cancel the squares, what you're essentially saying is, I'm going to distribute the square root across the addition. Square root does not distribute across addition, nor does it distribute across subtraction. Square roots only distribute across multiplication and division. So there's no distributive property that will allow me to distribute the square root across the plus sign so that it can get to the two squares. So I'm stuck with it, but that's okay. Might help if I write the correct thing here. That's okay. Because all we're doing is building a formula for distance, and here we have it. To calculate the distance between any 2 points whose coordinates you know, so first x, first y, second x, second y, the distance is the square root of the sum of the squares of the differences of corresponding coordinates. I'm going to write that sentence down. Distance is the square root of the sum of the squares of the differences of corresponding coordinates. I know it's a mouthful, but it tells you exactly how to calculate distance if you go from the bottom up. Find the difference of corresponding coordinates, square them, add them, and then take the square root. In the next video, we'll look at a couple of examples of calculating the distance between 2 points. Sometimes it comes out nice and clean, sometimes not so much.